So thank you for the presentation in this short contribution, which is joint work with Andreas Herzig. We have tried to answer a very simple question, namely what is the epistemic logic underlying this incomplete argumentation framework. So let me start clarifying the question by defining what an incomplete argumentation framework is. As you may know, a standard argumentation framework is just a directed graph where nodes represent arguments and arrows represent attacks among arguments. So an incomplete argumentation framework extends a standard argumentation framework by partitioning both the sets of arguments and the set of attacks into two disjoint sets, intended to represent fixed or known arguments in blue in the example, and red on unknown arguments and attacks. In order to reason with these kind of structures, the notion of completion is usually used, and a completion of an incomplete argumentation framework is nothing but another argumentation framework, so a directed graph, such that its domain is within this interval, so all fixed arguments are a subset of every completion, and every completion is a subset of fixed argument union uncertain argument. And something similar is required for attacks, but restricting both extremes of the interval to the domain so that we get a direct graph. Just to continue with the example, the set of completions of this incomplete argumentation framework is depicted here, so it has 3 completions. So we want to know what is the epistemic logic of this underlying this kind of structure. And the answer is given by the epistemic logic of visibility, which was introduced in the previous talk, but this is a very simple fragment of the logic that Frederick used. And in this version of the epistemic logic of visibility, which was studied by Andreas and some other colleagues, we have several kind of propositional variables which are indexed by a finite set of arguments that we call the signature sigma. And for the purposes of this talk, you can ignore the third kind of variables. So we have these awareness variables that will be used to describe the set of arguments of each completion, and these attack variables which are used to define the attack relation of each completion. And on top of propositional variables, we have the set of atoms of the logic, which are either propositional variables or this kind of visibility atoms, but differently what happens with the logic introduced by Frederick in the previous talk. We don't allow, because we don't need them, nested visibility atoms, all right? So these visibility atoms can be read also as the agent knows whether P is the case. Then we define the single agent epistemic language for signature using the atoms we just defined. But the curious thing is that with the semantics that will be given in a second, we can recursively eliminate the epistemic operator, reduce it to the visibility operator. All right, so the semantics of this epistemic logic of visibility kind of resembles Kripke semantics. But here the possible words are determined by propositional valuations, so by sets of atoms of the logic, and the indistinguishability relation that we call visibility relation is computed from the contents of each valuation. So basically 2 requirements should be met. The first one is that visibility atoms are kept constant through related valuation. And the second one is that if the value of a propositional variable is seen in a valuation, then this is kept the same in all related valuation. So the main result of the paper was to show that once we associate to each incomplete argumentation framework a natural propositional valuation over this set of visibility atoms, we have a natural correspondence between the set of completions of the original incomplete argumentation frameworks and the AFs represented by each valuation of the equivalent class of the visibility models. So we have strengthened these connections into further direction. The first one was to reduce so-called argument acceptability problems in incomplete argumentation frameworks to model checking problems in a multi-agent version of the epistemic logic of visibility I just introduced. And the second one was to find the minimal epistemic logic for incomplete AFs. And we said that is minimal because actually the epistemic logic of visibility satisfies S5 actions, and this is not assumed in incomplete AFs. So the logic that we found as the minimal epistemic logic for incomplete AFs is basically the extension of the model system K with these three actions. So for this talk, just focus on the two highlight ones. We have axiom D, and we have this kind of distribution over of the epistemic operator over conjunction disjunction of consistent literals. So let me conclude this short talk by recalling that we have established a strong connection among two seemingly unrelated formalisms in knowledge representation. And conceptually, we have found that incomplete AFs assume consistency of beliefs, which can be kind of acceptable because it's somehow standard in the syntactic logic. But also this distribution of K over disjunction of consistent literals, which can be a kind of a strong limitation for epistemic modeling in some context. So that was all. Thank you very much. And if you have questions, I'll be here and also in the poster session.